right, here we are, part 2 of the visual sensation perception notes.
Kyle Campbell,
Sorry.
can you stop by your classroom, please? Kyle Campbell, can you stop by your classroom?
Doing this at school. Here we go. All right, so what we're going to talk about here to start is this idea of the Gestalten principles of closure. Gestalt psychologists were people who kind of worked in the same perceptual field and studied and did research the same way, but they believe that we perceive things as an objective whole rather than isolated parts. Okay, so we'll get to it here in a second, but when looking at incomplete forms or shapes in our brains, we would actually complete those, much like when we were in class doing some of those reading activities, we would be able to complete the words, and that we do not actually look at all the minute details that go into it. So the law of Prägnanz, reality is organized and reduced to the simplest possible form. Okay, so here what we see is that the images are a series of circles rather than a much more complicated shape. So when we look at it, while yes, it looks very similar to the Olympic rings, but we make out the circles rather than the shapes that are created either inside the circles or during the overlaps of the areas where there could be like a Venn diagram. So we focus on the more simplistic and understood aspects of the image. So we always try to make things, it states that is, we try to make things as simplistic as possible, as orderly, as regular, as easy for our brains to understand. The next thing is we have figure ground. And you've probably seen this image before, many like it, but what happens, and what the law of figure ground talks about, is that when given these images, we have to make a conscious decision in our brains of what is going to be the focus as the figure and what is going to be the ground. And oftentimes as you shift that, you can see both of them. So for instance, in this picture, if you focus on the white vase, okay, then that is the figure and the black outline becomes the background. However, you can kind of look to one side or the other of the vase and you make out a face staring directly back at another face, and then the white becomes the background. Okay. The law of continuity gives us the ability to arrange things in as simplistic, a straight, smooth, orderly line as possible. Okay. So for here, our eyes are going to be drawn towards the clumps of dots that are creating kind of like a mountain peak, or the straight lines, or the logical patterns that are built in, okay, as opposed to looking at the outliers or the ones that don't seem to fit in. Proximity, okay, things that are closer together are usually seen to belong. Right? We see these vertical columns and horizontal columns, so we see them that way because of proximity, because they're closer together. Okay, they're closer either vertically or closer horizontally, and that's how they're grouped, is how we perceive that. Then we've got similarity, okay? Picture A, we've got the two vertical columns, of your apples and pears. They're evenly spaced. Picture B is the opposite. We've got the horizontal rows of the fruit, okay? So since they are of the same type of fruit and both organized in rows, we can clump them together as being similar, as opposed to having different patterns or different types of fruit that's represented in them, even though they are inherently different. The law of symmetry. So the law of symmetry states, that our minds perceive things as being symmetrical, forming a center point, being able to work around something. And then it's pleasing for us to be able to divide those objects into even symmetrical parts. Okay, so these parts give us the likelihood that these types of images will be clumped together, right? And we can kind of see, you see the eagle there with, what would be usually identified as the rays of sunshine going out, but making sure that they're symmetrical, as they are, as well as, our grouping of the parentheses and everything over there. So the law of closure. Here, the idea is that even though all of these are open, they've got breaks in them. Instead of looking at, say, the triangle as a angled point, we would look at that as being a triangle, even though those lines are not filled in, they're not completed. We don't look to the individual parts of the lines per se, we look to close those off and make sense of the larger image. Okay. So the law of common fate, the objects are moving in the same direction. We see them as a unit. Okay, so when these dots are all lined up evenly, horizontally, looking like they're pointing to or moving side to side on the screen, it's easier to identify them as a group as opposed to 6 individual dots. Okay. We've hit some of these, but here we are, we've got an image. Okay. Who knows what it is? Could be a goofy looking older man, could be an animal, could be whatever. When put in, just much like we did before, when put in here and given context, right? We see different closures. We see glasses, a nose, a mouth, kind of a frumpy chin. Well, in here, when put in this context, we see a rat or a mouse with ears and a head and eyes and legs and a tail. Okay. And our eyes can clump these into these unified groups because of these similarities, as we mentioned before. So some other things we do is we take things that are not in place and we try to make sense of them. Okay. We try to make sense of them. So here we are, we've got Julia Roberts, actress, upside down. Okay. But if we do this, yikes, that's just not right, hard to look at. Okay. Because our brains are now able to take the information and it's not matching up with what we believe to be normal, right? We're having a really hard time cognitively handling that. That, not so much. We understand she's upside down, but we get it. Okay, who's this? Probably doesn't take very long. You can identify this is Abraham Lincoln. Well, what do we see here? Okay, we can use those principles again in both the last two to be able to come up with an image. If you can't see it, we've got a Dalmatian in there. But you can look at the patterns to be able to connect them to create a whole. Boom. Okay. So, monocular depth clues. We've got things like texture gradient, right? A surface with a distinct texture extends into the distance. Okay, so details gradually become less clear as they get further away. So when you're looking at, for instance, a grassy hill, things that are close up are a little bit more detailed, like the grass and the dirt and the rocks. As they get further away, a little bit less so. Interposition, occlusion. This is when something blocks something that you're looking at. It occludes the view of something else. And it lets you know it's further away. So if you're looking at something and you've got maybe one of your friends is standing in front of your other friend, but you're a distance away, you know who's closer because the first friend is obstructing part of the second friend. Okay. From a personal standpoint, you can kind of do this. I watch a lot of football on the weekends, and sometimes it's tough to tell if a field goal goes through. So what you have to pay attention to is whether you can see the whole ball, whether it covers up the field goal post or whether it goes around it. Okay, so that's one way to use it. Linear perspective. Parallel lines seem to meet in the distance. You've probably seen the images of like desert roads or railroad tracks that extend far out and it looks like they're touching. Okay, the further away they go, the more it seems that they join together. Aerial perspective and clarity. Distance objects are usually less clear than nearby objects, right? The cues, especially apparent outdoors, and we'll see an example of that here momentarily. And then shadows and shades. Let's know where the light source is located, right? So if you have a shadow off your left side, you know there's a light source on your right. Okay. Height and vertical plane. Near objects are low in the visual field. More distant objects are higher. Relative size. Two more objects are assumed to be similar in size. then the object that is larger appears to be closer. Familiar size. If you're very familiar with the size of an object and it appears to be very small, it must be far away, and vice versa. Motion parallax, when you're moving, you use the speed of passing objects to estimate the distance. So the objects that are closer to you, say a guardrail on the freeway, goes by really fast, so you know it's fast. If you look way out in the distance at a far tree in a field, it doesn't go so fast. Accommodation. Okay? This is when you're focusing on distant objects. The lens flattens, right? We talked about the muscles in the eye changing what it is you can see. Okay? It changes, and to some degree we use the information provided by the muscles to control the shape to judge our depth. And the younger we are, the stronger our eyes are, and the more easily we can switch back and forth. Depth perception, right? That type of stuff. But the older we get, it becomes more tough. Okay? If you want to start to practice some of these visual cues, check out some Bob Ross. The guy's a master. Okay? So all these things can be found in some of his videos. And here's one. So you can go on and you can watch this on your own. I'm not going to play it here, but have fun with it.